Hello students, today we are going to take up the revision of chapter 9 Study of Compounds-Ammonia. Let us start this topic with a very good thought, focus on the good. There are situations in our life where good and bad things simultaneously happening in our life, but our concentration, our focus should be on the good things, and in this way you will be able to manage whatever the bad is happening. If you try to concentrate on bad, then good will be ignored and you will be landed in some another big trouble. So that's what we want to say, that focus on the good. So we are going to start the topic here, that is ammonia. You know that ammonia is a polar covalent bond. It is having 3 bond pair and 1 lone pair. If you are talking of physical property of ammonia, ammonia is a colorless gas but pungent smell. It is lighter than air and it's alkaline gas, means if moist red litmus is brought near to the gas, it will turn blue. And one more test is there in regard to that. When a rod dipped in concentrated HCl is brought near to the ammonia, it will give dense white fumes of ammonium chloride, and it is highly soluble in water. So let us discuss next part, that is lab preparation of ammonia. Lab preparation of ammonia, if you see your book, there are 2 diagrams given for the lab preparation of ammonia. First is with the slake lime or calcium hydroxide and ammonium salts. Ammonium salt, you can take ammonium chloride, you can take ammonium sulfate, but normally whatever reactions you are seeing is with the ammonium chloride. But don't take ammonium nitrate, because ammonium nitrate is an explosive compound, so it can explode, and moreover it is not giving us the ammonia and nitrogen compounds they are giving. So that's what the problem is there with the use of ammonium nitrate. So now as you see that ammonium chloride and slake lime is heated in a round bottom flask, and the gas is dried by the use of which drying agent, that is quicklime, and dry ammonia we can collect. Okay. Next is in regard to ammonia collection. You know already we have discussed that ammonia is lighter than air. So lighter means upward delivery, and whatever the gas will be there, that will go down. Okay, so it means downward displacement of air, because ammonia is lighter. Similarly, all the gases which are lighter, it will be collected by upward delivery, and those gases which are heavier, that will be collected by downward delivery, because it will go down and air will move up. Okay, so the basic concept you should be clear. Earlier we have discussed about the lab method of preparation, and in that I told you that one method is there like ammonium chloride and calcium hydroxide, that method heating, and this method is commercial preparation. Lab also one more method is there. When the question will come, we will brief you about that, but now we are not talking of lab method, I am talking of commercial method. Commercial means large scale preparation, large scale manufacturing word we are using mostly. So reaction is HABER process. Nitrogen plus 3 hydrogen gives 2 moles of ammonia gas. Condition here, pressure is 150 to 200 or greater than 200 also is written in the book. Temperature is 450 to 500 degrees Celsius. It comes out to be 773 Kelvin. And iron, finely divided iron as catalyst, along with molybdenum, that is promoter. Okay, instead of that molybdenum, aluminium oxide is also used. So that also you will find in the book. So here what we are going to take is nitrogen we are taking here, hydrogen we are taking, mixing these 2 gases and increasing the pressure and putting in the chamber containing the catalyst, and then you separate the gas. Sometimes because only 10 or 15% will be converted to ammonia, balance will be nitrogen and hydrogen, again it will be returned back. Nitrogen and hydrogen again will be returning back in this way. This way it will go back and ammonia we will collect. And how to separate these gases? By liquefaction. Liquefaction means we are decreasing the temperature, and the gas first will be liquefied will be ammonia. Nitrohydrogen will not be liquefied, it will be sent back, and ammonia we can get back. So here approximately 10 to 15% only yield is there for this reaction. Mean to say that if I am taking this 1 mole, then only that 0.1 only we are getting in the products. So now next is fountain experiment. Fountain experiment is basically to show the high solubility of ammonia gas in water. So what is going to happen here? You can see this trough containing the red litmus solution, and this is a capillary tube that is dipped in this trough and it is attached to the round bottom flask, and it's totally foolproof and nothing, no air can move in. And this is a dropper here with a rubber bulb and it's containing water. When you press it, the water will move in, and as you know that ammonia gas was there, ammonia gas will absorb water because it's having high tendency of solubility in water. So thereby what is going to happen is thereby vacuum will be creating here in the fountain experiment. So once vacuum is created, you know that as compared to the when you will be sipping the juice through the straw, the same manner what you are doing is you are creating the vacuum in the mouth. So what is going to happen is this red litmus solution will move up, and you know that red litmus solution when it comes in contact with the ammonia gas, it returns into blue. So that is what the fountain experiment is. It is explaining the high solubility of ammonia gas in water. Sometimes student will say, sir, it is also explaining the basic nature. Yes, of course, but when the question is asked about that fountain experiment, what it will represent, you have to tell that high solubility of ammonia gas in water. This is the basic in this experiment. Now, ammonia is acting as a very good reducing agent. Reducing agent, you can see how it is. So for example, copper oxide is there. Copper oxide is black in color, and copper oxide is changed to copper. So it means what happened? Loss of oxygen. Loss of oxygen means what? Reduction. Reduction. Who has done reduction? Ammonia. Ammonia is acting as reducing agent. So when you heat copper oxide with ammonia, you will get copper, reddish brown metal with a colorless gas. And this colorless gas we have collected here over the water. Okay, being lighter. So understood that? So sometimes question being asked is, what do you observe when copper oxide is treated with ammonia? You can write that black color of copper oxide changes to reddish brown metal with the evolution of colorless, odorless gas. Okay. So next is chemical reaction of ammonia. So chemical reaction of ammonia does not burn in air or support combustion, but it burns in oxygen with a yellow flame, forming nitrogen and water vapor. So ammonia plus O2 give rise to nitrogen. This is a burning of ammonia. Please remember that. And this is the flame we are getting here. So yellow flame is obtained. And here when you are reacting with ammonia, this is burning is there. Okay. Next is OSTWALD process. So here also you see the reactions you will see next. So see this reaction. Ammonia plus O2 give rise to NO and water. Here also is there. This is not burning. It is in the presence of catalyst. Please do understand that. That's why I compared these two reactions. This reaction is without catalyst, and this reaction is with the catalyst. Okay. So now we are going to discuss about the OSTWALD process for manufacturing of nitrogen. Manufacturing word means large scale, commercial method. What you are doing is you are adding ammonia, NH3. Here something is missing, NH3 and O2. 1:8. It's not 8 volume of O2, it's 8 volume of air actually. Okay, but actually reaction will take place with oxygen because nitrogen will not react with the ammonia. So ammonia and O2 reacts to form NO in the presence of a catalyst, platinum. And NO is converted to NO2 by treating with oxygen. And then NO2, then when comes here absorption tower, what will be sprayed here, and oxygen is in excess. What is going to happen is NO2 plus O2 plus water give rise to HNO3. This is the quad piece is used for the more absorption of nitrogen dioxide gas in water, and it provides the more surface area for absorption of this gas. So this waste gas will be there. Waste gas means what? Oxygen would be there, nitric oxide also will be. It will be recycled back. It's not, we are not throwing it back into the atmosphere. It will go recycle back into the system. Okay, so what are the reactions? Ammonia and O2, as I told you already, air we supplied, but we are writing reaction with O2. Okay, this reaction is very easy to remember. Platinum 800 degrees Celsius, 45, 46. 45, 46. Ammonia plus O2 give rise to NO and water, exothermic reaction, catalytic reaction. And the second step is NO plus O2 give rise to NO2. Delta H is negative. NO2 plus water give rise to HNO3 plus NO. So sometimes this reaction has been written in this manner also. NO2 plus O2 plus water give rise to HNO3. That way also is correct. Both way it is correct. Okay. Now, reactions of ammonia with mineral acid. Ammonia is a base. Base plus acid gives salt. This is the basic reaction. So ammonia plus HCl give rise to ammonium chloride, dense white fumes. Ammonia plus HNO3 give rise to ammonium nitrate. Ammonia plus sulfuric acid give rise to ammonium sulfate. Ammonia 1 valency, sulfate 2, cross multiply ammonium sulfate. Uses of ammonia. Ammonia is an important industrial agent. Used as a fertilizer also. We can produce urea from the ammonia. Chemicals. We can prepare nitric acid, just we have done with the OSTWALD process, and sodium bicarbonate, sodium carbonate, hydrogen cyanide, hydrogen, explosive ammonium nitrate, and fibers and plastic and nylons, and cleansing agent. So, emulsifier properties there in cleansing agent, mining, metallurgy, pulp and paper, pharmaceutical, refrigeration, cooling agent. Ammonia is also using as cooling agent in the ice factories. Okay. Now, precipitation reaction. These are reactions which we studied in analytical chemistry chapter number 4 also. But here we can go for a brief discussion of copper salts when treated with ammonium hydroxide solution. What is going to form is pay blue precipitate. So this precipitate, when you add excess of ammonium hydroxide, it will turn into deep blue solution. Okay. So it means this precipitate will dissolve when you are adding excess of ammonium hydroxide due to formation of complex. That is known as tetramine copper complex. Okay. So what I want to say is you have to practice the reactions of calcium, ferrous, ferric, lead, zinc, copper with ammonium hydroxide. The color you should be aware of that color. The calcium is not reacting with ammonium hydroxide. Ferrous is giving dirty green precipitate of ferrous hydroxide. Ferric is giving reddish brown precipitate of ferric hydroxide. If you are talking of zinc, is giving zinc hydroxide precipitate, but in excess it will be soluble. Lead is giving you lead hydroxide chalky white precipitate, but it is insoluble in excess. And the copper is giving us the copper hydroxide pale blue precipitate, and in excess it will change into deep blue solution. If you have forgotten all these things, please refer practical chemistry page or chapter 4 analytical chemistry. These reactions are there in the ammonium hydroxide reactions with copper, zinc, lead and calcium salts. Okay, ferrous, ferric also. These are the reactions which are very important. Let us study one by one. First reaction, you must have already studied that. The first is lab method of preparation. This is the normally student did not write that heat. Please, we should write the heat also. Ammonium nitrate is explosive nature. Therefore, we are not using in the preparation of ammonia also in the lab preparation. Okay, and moreover, it is giving laughing gas N2O. Similarly, calcium plus nitrogen gives rise to calcium nitrate. I was talking about the two lab methods of preparation in the book. So, first method we have discussed the previous, the second is here. Calcium nitride, magnesium nitride reacting with boiling water give rise to calcium hydroxide plus ammonia or magnesium hydroxide plus ammonia. This is the second method of preparation of ammonia from the nitrides of calcium and magnesium. Okay. The next property is reducing agent property. Lead oxide is changes to lead. Reduction takes place. Who has done? Ammonia. So lead oxide is reddish brown when hot, yellow when cold, and lead is grayish metal luster. Grayish white also sometimes is used. Ammonia plus chlorine give rise to NCl3 plus HCl. Ammonia plus carbon dioxide give rise to urea plus water. So this was we have discussed in the preparation of the uses. Ammonia is used in the preparation of urea. This is the reaction. Ammonia plus carbon dioxide at temperature of 150 degrees Celsius, 150 atmosphere. Urea will be there along with water. Similarly, ammonia plus chlorine give rise to NCl3 plus HCl. Okay. So here the reaction is when chlorine is in excess, then only this reaction takes place. If ammonia is in excess, ammonium chloride plus nitrogen will be formed. Please do remember that. So here these are the reactions which we are talking of. Ferrous sulfate, that is giving dirty green precipitate. Ferric will give reddish brown precipitate. Lead will give chalky white precipitate. Zinc will give gelatinous white precipitate. And in excess, this precipitate will be soluble due to formation of complex. Tetramine zinc complex. And if ammonia is in excess, previously reaction we were talking of, so here, see ammonia is in here, in this case ammonia, chlorine is excess, NCl3 is formed. Okay, so now if we are having ammonia is in excess, and ammonium chloride will be formed along with nitrogen. And 45-46, you should be able to remember this reaction. 45-46, that is the OSTWALD process. Platinum at 100 degrees Celsius, NO plus O2 give rise to NO2, and ammonia plus chlorine give rise to NCl3 plus HCl. This we have discussed already. Okay, so now this is a test for detecting ammonia. Moist red litmus paper, it turns blue. Okay, or indicators, pH indicators can be used. Indicator spelling you have to 55. Pungent spelling. Dense white fumes with HCl, it turns colorless necessary region to brown. So let us do some question. Ammonia uses reducing agent in reducing copper oxide to copper. Yes, ammonia. Write a balance equation for the lab preparation of ammonia. Ammonium salt. I already told you, you should not take ammonium nitrate. Okay, otherwise we can take ammonium chloride plus calcium hydroxide. Heating is also required. Next is reaction of ammonia with excess chlorine. Please do remember, excess chlorine and NCl3 will be formed. See. Okay. Next is ammonia plus H2SO4 give rise to ammonium sulfate. Acid plus base gives salt. Action of warm water on magnesium nitride is the second lab method of preparation. Magnesium Mg3N2 plus water, boiling water should be magnesium hydroxide plus ammonia. Ammonium nitrate is used in the preparation because it is explosive in nature. Drying agent used in the preparation of ammonia is calcium oxide. How is ammonia gas collected? You know, lighter it is. So what it will displace? Air will displace downward. Not collected in water. It is highly soluble in water. So this is the reaction. This is the reaction. You see that this gas is ammonia and mixture. You know that ammonium salt will be along with calcium hydroxide. So gas is ammonia. Balance equation: ammonium chloride plus calcium hydroxide give rise to calcium chloride plus water plus ammonia. And how is the gas being collected? Downward displacement of air. Drying agent is quicklime. How you find the gas is full jar? Not dipped in, concentrated actually is brought into it. It gave dense white fumes of ammonium chloride. Dense white fumes we should try. Precipitate we can avoid. Ammonia can be obtained by adding water to magnesium nitride or aluminium nitride. Okay, boiling water. Alkaline gas dense with white fume with ammonium hydroxide is ammonia. Copy and complete the table. This is a very important question. HABER process is there, OSTWALD process is there, and contact process is there. Contact process we are done in sulfuric acid, HABER process in ammonia, and in OSTWALD process in nitric acid. Okay, so these are the very important questions from this particular topic. Okay, so one only reaction is written in OSTWALD process and contact process because this is a catalytic reaction, very important reactions. 45-46 and sulfur dioxide converted to sulfur trioxide. Write a balance equation in which ammonia is oxidized. Metal oxide. Metal oxide you can take lead oxide or copper oxide. Okay. Next is gas which is not oxygen. And what is produced is nitrogen. Name of substance used for drying ammonia, that is calcium oxide or lime. Write equation to illustrate copper oxide plus ammonia. Okay, and copper oxide black is reduced to reddish brown metallic copper. HABER process conditions are what? Temperature 400 to 500, pressure greater than 200. Finely welded iron, promoter is molybdenum. Mixture of ammonium chloride and slaked lime. Again, this reaction is there. This is a summary exercise for you. This aluminium nitride and magnesium nitride, two reactions are there, very important. So this type of question can also be asked. Nitrogen plus matter give rise to compounds. X plus water, ammonia plus other compound. This is nothing but magnesium nitride would be. Okay, so this way here is metal, magnesium. So you can see from here. So next was the question is asked is at what high temperature condition required was asked. Magnesium hydroxide is formed along with ammonia, demonstrated as reducing net property. Burning is without catalyst, N2 is formed in this case. Catalytic is 4546, platinum 800. So if you find something you want to see, you are not clear, you can stop the video and see that. So okay, what do you observe when ammonia is reacted with oxygen has absence of catalyst? It's greenish yellow flame. And the catalyst platinum 800 degrees Celsius, reaction takes place high temperature. Here question can be asked is, catalyst glows red. Why? Because it's exothermic reaction first of all, and it's taken as high temperature, and moreover exothermic reaction will continue to increase the heat. What is the name of industrial process? OSTWALD process for preparation of nitric acid commercially. What do you observe when ammonia will bubble through red litmus solution? It will turn to blue. Balance and equation solution, ammonium chloride and sodium oxide mix. So this is not the lab method preparation, this is just a testing methodology. Ammonium chloride plus NaH gives rise to NaCl, water and ammonia. So thank you students.